You know, the kinds of things that you can accomplish today in virtual machine migration, it's just fundamentally impressive. It wasn't that long ago when actually doing migrations of virtual machines was something that we really wished for. And even in Microsoft and some of the early editions of Hyper-V, the only option that we really had for moving virtual machines around was this not entirely awesome option called quick migration. People complained about quick migration early on because unlike its equivalent in VMware, the vMotion activity, quick migration actually, doing a quick migration actually invokes a very tiny little period of downtime for that virtual machine to move. Well, because of all the competitive pressures that Microsoft saw out of VMware, the amount of pressure that VMware put on them was nothing short of ridiculous. Microsoft very quickly created their own live migration solution in later versions of Hyper-V, Hyper-V version 2, Server 2008 R2, that supported the complete live migration of virtual machines without having to power them down or you don't even really power them down, have any kind of loss of connectivity during that migration period. Since then, we've also added to the quiver of capabilities that we have here with VM Movement, the ability to not only migrate the virtual machine, but the storage that that virtual machine sits on top of. I like to think of the difference here as the brains of the virtual machine and the body of the virtual machine. And so if I kind of redraw these, the brains of the virtual machine are the configuration file. So really the XML file that contains all the information that defines that virtual machine. The body is much larger. This is the VHDX file here in Hyper-V that corresponds to the virtual disks that make up that virtual machine. What's important to recognize about the difference between either of these first two, live and quick migration, as opposed to storage migration, is just simply that the amount of data that's required in a storage migration is orders and orders and orders of magnitude larger in size. So the process to do a storage migration, it's awesome, and it can actually, very impressively move a virtual machine, its disk, from one place to another without shutting the VM down or having any loss of connectivity. But because this is just so big, it's going to take a really long period of time. Now in this nugget, I want to talk about really the four different kinds of ways in which virtual machines can be moved around. And when you look at those four different kinds of ways, they can happen in Hyper-V alone, or they can happen inside of failover cluster. As part of a failover cluster. And so you kind of got to think of these things in two different ways depending on if that virtual machine is considered highly available or not. Yet another of the new features that we now get with Windows Server 2012 is the notion of clusterless live migration. And clusterless live migration is a fantastic new solution because you can actually have a virtual machine running on a single Hyper-V host that is not a member of a cluster that you literally migrate over to another Hyper-V host and the machine still runs. It is just amazing. It's amazing how little there is to see because it just simply functions. You can do the same thing with clusterless storage migration as well. You can actually, and this is the part that's really fundamentally cool, if the VHDX files, the body of these virtual machines, are sitting somewhere on a file share, you can actually do a clusterless live migration of just the brains portion from one Hyper-V host to the other without invoking any kind of outage either, and without having to have a cluster. So with cluster, without cluster, you've got live migration, quick migration, storage migration, and the import-export functionality that now exists here in Windows. Now, that's all the awesome part. And in a second, I'm going to show you how all this works. It's really, clicking through it in the interface, there's really not that much to see. So it's more about thinking about these things with your brain than is it with actually clicking buttons in the interface. The live migration functionality is perhaps it is the most exciting of these. And so there are the most prerequisites that are required in order for live migration to function. Not the least of which is the fact that the processors you're using between one type of machine and the other have to be of the same manufacturer. So we're talking about AMD versus Intel here. If you have some machines that are on Intel and some machines that are on AMD, and you're trying to do a live migration from one to the other, you're not going to be able to do that. In order to be able to move a machine from one type of processor to the other, the only way you can really accomplish that is by doing a a powered off migration or an import export copy. So plan on consolidating on a single processor manufacturer, because that live migration functionality is just not going to work anytime you're going from AMD to Intel. Really, common expectation for a test question here, because AMD to Intel is just not going to fly. Now, inside of Intel or inside of AMD, there are going to be a variety of processor types as well. So your Nehalem, your Westmere, your Sandy Bridge, your so on and so on and so on in the Intel space. And each of these processor generations, I'll just call them, generation 1, 2, 3, 4, 5. Okay, so Nehalem, Westmere, Sandy Bridge, blah, 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 blah. Each of these processor generations is going to add additional functionalities, additional feature sets to the types of instructions that the processors actually support. Because of that, you sometimes also have problems with live migration when you're trying to go from different processor families to other processor, from one processor family to another processor family that's too far away from the original processor family. There is the ability, and I'll show you what this is here inside the interface, to kind of dumb down the processors so that you'll have full compatibility across all the different processors that you may live migrate across. But be aware that there is the need to turn on this processor compatibility, and doing so is something you're going to want to do only if you have the need to live migrate between machines. I will also tell you there is this really not well known limitation to live migration too, in that your virtual switches need to be named the same. If you have virtual switches that aren't named the same, well, you're going to end up with a problem with live migration. The automatic live migration, if you do an actual move, you'll get an error message, but if it tries to do some sort of cluster-based live migration, it's going to fail. Also, physical devices like DVDs can cause a live migration to fail. If you have a physically connected DVD drive on a virtual machine, it's not going to live migrate because it's going to end up disconnecting itself from that DVD drive. Now, in some circumstances, relatively rarely, you may want to accomplish what is called a quick migration. The quick migration is what we had back in the Windows Server 2008 RTM days. It was the only solution that was out there. And you might think that quick migration is just a marketing term, but the quick migration is technically faster than the live migration. But the virtual machine does experience a short outage. Quick migration also uses less bandwidth because there's no syncing of the experience from one host to the other, as it's ensuring that machine never goes down. So if you have a need for a really fast migration, you know how those test questions can sometimes be worded in weird ways. If you need the fastest kind of migration or the one with the least amount of bandwidth, well, then you're looking at a quick migration. Now, the last step in here is really the worst option, which is this import and export of virtual machines. The import, the export, the copy of virtual machines, again, is something if you're trying to go from Intel to AMD or vice versa. It's also your last and final step if you, for some reason, just can't get that virtual machine migrated. The import, export, and copy process requires you to power down the virtual machine, export it from its existing location, copy it then to a new location, and import it into that new location. So power down, export, copy, and then import before you can power back on. And the reason for this multi-step process here has to do with how a virtual machine in Hyper-V needs to disconnect itself from its Hyper-V host. That disconnection process is different here than what you would normally see in a VMware environment because of the way that Microsoft deals with some of its synthetic drivers. So there actually is this import and export process that is required if you plan on doing a manual copy of a virtual machine from one place to the other. Another very common test question here, because if you're going to do a copy, a regular copy, plan on doing an import export as it relates to that process. So plenty of things here that you got to be aware of. I want to show you how these look here in just a minute, but there's definitely some caveats here that you need to know for the exam, and you need to know because sometimes they may come to bite you whenever you're working in your environment. I do want to show you also just a couple of things that I kind of punted to this nugget. The first of which is when we were talking about failover clustering roles, there was that one topic on VM monitoring that I kind of punted over here because I wanted to get the Hyper-V environment up and running. And the second is our conversation that we had back on that last nugget on guest clustering. I told you that in order to create a guest cluster, a cluster of virtual machines, the only way to accomplish that was by, or one of the new features in accomplishing that had to do with what is called a shared VHDX file. I want to start by showing you that shared VHDX file so that you will just know if you ever need to do guest clustering. Here I am on the server clust3, the third of my 3 cluster servers that we were working with before, and I've created a new virtual machine here called VM1. I just brought him up here because I want to show you under settings. For the hard drive here, under advanced features, there is this thing called virtual hard disk sharing. And it is here, the purpose of this is really for you to do that kind of guest clustering anytime you have to do shared storage between virtual machines. Turn this on and then connect up to the virtual hard disk that is to be shared, and then you'll be able to do exactly what you're looking to do with guest clustering. So this is the shared VHDX feature. Be aware of what that is. Now this virtual machine right now is not actually connected up, or is not actually part of the cluster that we've created. We can take a look back here and look at the hard drive for this VM to show that the virtual hard disk is currently on the physical host. So it's on the C drive of this host in users public documents Hyper-V virtual hard disks. So I can show you before we actually get into the clustered world how I can go about performing some of these live migrations and quick migrations and storage migrations and so on. But before I do that, I need to show you one other setting here that relates to the Hyper-V host that will determine exactly what kinds of features you will have available for actually doing this clusterless live migration. The one that you're most interested in looking at here will be the, under live migrations, under advanced. Well, first of all is the fact that you need to enable outgoing and incoming live migrations and then determine which network you want to use. But you also over here under advanced features want to determine which of the 2 authentication protocols that you will use in order to facilitate these live migrations, to authenticate them. There are going to be some consequences to each depending on which one you choose. If you choose to use CRED SSP, there's no additional configuration that's required. However, you have to log on to the server to perform the migration. In other words, you've got to be on the source Hyper-V host in order to initiate that live migration. That is not entirely workable in most environments because you want a remote console to be able to accomplish these things. And so most people want to use Kerberos. But in order to use Kerberos, you have to set up what is called constrained delegation for live migration. And that is a step that requires you to accomplish some nifty stuff inside of Active Directory users and computers. Let's take a look at where we would set up Kerberos constrained delegation here in this environment. I'm going to assume that I'm going to need to migrate virtual machines among the machines clust1, clust2, and clust3. In order to do that, I've got to come over here to the delegation tab and actually enable the other machines to participate in this constrained delegation. I do that by selecting this button here, Trust This Computer for Delegation, and for the authentication protocol I'm looking for, I'm going to look for the authentication protocol on the other machines. So here's clust2. There are 2 services that I'm interested in making available for this constrained delegation. The first is the CIFS service, and the second is the Microsoft Virtual System Migration Service here. So there's Microsoft Virtual System Migration Service. Whoops, I forgot for clust2. And there is the CIFS service as well. So these 2 need to be turned on for clust2. They also need to be turned on for clust3 to provide the authentication, or the OK, so that we can then end up migrating these machines around. So there's CIFS, and there's the Virtual System Migration Service right there. So if I see those, there's that for clust2 and for clust3. I need to accomplish the same thing now on clust2 and clust3 for the other machines. So here I'm going to do again the authentication protocol clust1 and then the CIFS and the Hyper-V, the Microsoft Virtual System Migration Service. Got to do this for clust1 and for clust3. Let me pause things. So I'm going to go through doing all these because there's, what is there, 6 of these that have to get done. And when we come back, we'll be done, and I'll show you how we can go about the next step and actually doing a live migration. And we're back. So I'm back here on Cluster 3 now, and I've done all the work over in Active Directory. The real kind of weird part about that is that I have to do it for every single Hyper-V host in the environment that I plan on doing that live migration with. So you're going to be going back in there from time to time to enable the delegated or constrained delegation in Kerberos in order to do this clusterless live migration. After you've done that, the process to move the virtual machine happens by clicking on the VM and choosing Move. I can choose to move the virtual machine or the virtual machine's storage, or both. Again, the brains of the VM, the smaller amount, and the body of the VM, the much larger amount. And I just really identify which machine I want to move this to. So Clust 2, for example, being the machine I move it to. Choose OK, choose Next, and here's where I can choose when I move that virtual machine. Do I want to only move the virtual machine, or do I also want to move the virtual machine's data as well? If I were to click Next here and complete the process, it would go through and actually move that virtual machine from Clust 3, this is this machine, over to Clust 2, and it would disappear from this interface. There's not much to see there, and actually the storage migration can take a really extended period of time. So I don't want to waste that time having you just kind of see that, wow, this machine has disappeared. What I do want to show you are the extra features that you get whenever you start working this virtual machine into a clustered environment. Before I do that, let me show you just here the export. This is the place where you're going to export that virtual machine. Don't forget, if you're going to manually copy a virtual machine, you have to export it and then import it. Export, copy, import. That process is very important. Okay, so let's talk about how we do things with clustering, because this is really what we want to do. And in all but the smallest environments, having a cluster is the best solution because it allows the cluster to migrate around those virtual machines. And I don't end up with losing a bunch of VMs if my host powers off. So let's go about actually making this virtual machine highly available as part of the cluster. I've got to do that through a couple of different steps. The first of which is to bring up the Failover Cluster Manager wizard here. And then from within the Failover Cluster Manager wizard, I'm going to add this virtual machine as a new role. I'll right-click to configure the role. I'll choose Next here. I'll come down to Virtual Machine. And then I can select the virtual machine that's on this host, VM1, that's currently running, to configure it for high availability. Now, when I do that, one of the things that's pretty curious about the process you'll notice is that configuring the virtual machine for high availability completes the process, but doesn't do it actually correctly or fully. There's an interesting warning here that says, hey, wait a minute, the disk path for this and there's my cell phone. You go away, go away. Bonus points if you can actually if you can actually tell what that song was. Bonus points. Anyway, the disk path here is set to a local path. C, Program Data, Microsoft Windows, Hyper-V. So this is kind of a weird situation we've put our virtual machine in, because the virtual machine is now considered to be highly available, but it's not actually going to move around like we want it to. We need to get this virtual machine now, the storage of this virtual machine, brought into our cluster shared volume so that it can migrate around with the virtual machine itself. The good news is that there is a way to accomplish that thanks to the power of storage migration. So let's do a storage migration where we do a movement of the virtual machine storage. Notice here in the Failover Cluster Manager that I have a live migration and now a quick migration as my options. I only had live migration available before when we were doing the clusterless live migration. But we're not interested in either of those right now. We're interested in moving the virtual machine storage. So here's my VM, VM1. I have disconnected the DVD drive because I don't want to have that DVD drive connected up for the purposes of doing this live migration. And here is the cluster storage volume, volume 1, that we want to move this thing to. The way in which I move it is by simply clicking and dragging it to move it into this location. I can add shares if I want or do some other fancy footwork, but I don't need to do here at this point because I just want to get this thing here onto my cluster shared volume. Now you'll see when I do that, it's going to go ahead and go through the virtual machine storage migration. I'm doing this because I want you to be aware, again, of just the extra amount of time that's required to get this stuff moved over, because we're literally copying over 8 gigs of data. So we've got to get this thing moved over it's going to take a period of time for this thing to move over. One of the things I should show you is that if we take a look here at this computer, when I create a cluster shared volume, the volume actually gets presented to this host in a way that is slightly different than the traditional available storage that we would see with other kinds of cluster resources. That actually gets provisioned here in a subfolder of what is called C cluster storage. So this is the CSV. You'll notice in the CSV, here is volume 1. This is a pointer to the actual CSV itself. And if I go here, I'll find that virtual machine that is in the process of being migrated over. Notice here, what is it? 38 megs right now. If I refresh it, it'll take it'll be another little bit after it goes through the refresh. But since we're going through this process, you can see it just kind of slows down here. And it will take a period of time for that migration to complete. Let me go ahead and pause things. When we come back, we'll have this virtual machine migration complete, and then we can go through the other types of VM movement here in this environment. And we're back. So the migration of that virtual machine took a pretty extended period of time. In fact, so much so that I actually left for the afternoon, went home, had dinner, slept, had breakfast, and came back. It was complete at this point. So it doesn't take that long, but it was, I think, longer than I wanted to spend here at the end of the day. I do want to show you that now that we've completed this process, that you can see down here on the resources for this virtual machine, that we now have this virtual machine attached to the cluster, here cluster volume 1 and cluster disk 2. So we are now running very obviously here on our cluster shared volume. This is a really good thing. The other location where you can kind of take a look at if you want to see some of the characteristics of this virtual machine is the settings screen. Same settings screen here. We're essentially just grabbing it from the Hyper-V Manager. And if I take a look here at the hard drive is here under C Cluster Storage Volume 1. So successful migration here of that virtual machine's VHDX file, the body of the virtual machine. So we now have it fully HA aware and fully on top of this cluster. Now I told you in the beginning of this nugget that there were a couple of different additional topics in addition to the live migration kind of topics that we wanted to talk about here. These are things that kind of go hand in hand with the different migration kinds of things, but they're not directly migration. They just sort of facilitate the when migrations activities can occur. And these are network health protection, they're the drain on shutdown feature, they're the VM monitoring feature that we moved over from that previous nugget on failover clustering roles. And then I also want to show you a couple of places here in the settings for a virtual machine where you can do some little careful configurations to maximize your migration potential. The first of which is this processor compatibility feature that I mentioned earlier. And that's found here under processor compatibility, and it is this little checkbox right here, marked processor compatibility. Now this again is not so much for migrating things from one vendor to another, like Intel to AMD or AMD to Intel, but is instead when I have different processor versions, so the different families of processors that exist out there. When I enable this, it has the equivalency of kind of dumbing down the processor. It's not a bad thing. You're not going to significantly reduce yourself in terms of performance, but the advanced features that you would get from some of the later versions are going to be masked out so that you can end up migrating those virtual machines over. I also want to mention too that we talked a bit about the different virtual switches and naming of the virtual switches. You'll see here that this network adapter has a switch called virtual switch. Now when you go about configuring your Hyper-V hosts, it's generally a good idea, I'm back here in the Hyper-V Manager, to go to your virtual switches and make sure that you set that virtual switch with some kind of different name. This is the name of the virtual switch and not the external network name here, which is related to the network card on this Hyper-V host. I think the default name for the virtual switch will actually be the NIC name with a dash and then whatever name you assign to it, the actual label that you've assigned on that network card. So pay very careful attention here on your Hyper-V hosts to make sure that your switches are named the same so that you don't end up limiting yourself from being able to do an automated failover whenever you really need to. couple of the other new functionalities that are available here, the first of which is this notion of the protected network. Now, I want to show you down here under advanced features, yes, right here, this item here called protected network. And the protected network is kind of a cool feature because it can help protect you from having a situation where a live migration, a failover, if you will end up moving you to some location where you're not actually going to be able to talk on the network. So what this says is go ahead and move the virtual machine to a different cluster node if for some reason you end up seeing a network disconnection. So don't end up leaving this machine in a location where it can't talk on the network. Just take charge and go ahead and move that virtual machine around. Another feature that's worth knowing for the exam is one that's called drain on shutdown. There's one that's probably better to know for the exam than in reality because by default here in 2012 R2, the drain on shutdown feature is actually enabled by default. So you kind of got to know this because you could disable it, not that you probably ever really should. Now, when we're talking about the different nodes that exist here, if you're planning on doing maintenance on a node, I think I talked about this in a previous nugget, it's generally a good idea to take this node and put it into pause mode or maintenance mode before going about rebooting things. Remember, it's always a better idea for me to live migrate off the virtual machine than for the cluster to have to invoke an actual failover. The reason for this is because a failover, if I yank the power cord out of the node here, is going to require some outage, some downtime for that virtual machine. When you do that, if you pause and drain the roles, that's really a good idea. But also when you put those clusters into maintenance mode, there is a feature, this drain on shutdown feature, that will automatically migrate off any of these roles off of that cluster node before it gets put into, as part of the putting into maintenance mode. You can actually, if I pull up my PowerShell prompt here, you can adjust this functionality, but to be honest, this is something you probably would never really want to do. If I do git cluster and then FL star here, I can look for drain on shutdown, which should be actually, where did it go? Where did it go? Right here, drain on shutdown. Drain on shutdown equal to 1 means that, yes, when you attempt to put that machine into maintenance mode, it is going to drain off all the virtual machines and other roles. Very intelligent thing to keep your virtual machines up and operational. Also want to talk about the VM monitoring, kind of really cool functionality that you can dig ever deeper into your virtual machines to see, hey, maybe if a service goes down, I want the cluster to manage the services on the virtual machine. Nifty little solution here. For the VM monitoring, this is something, if I take a look here at this virtual machine, not the cluster object, but the virtual machine object beneath the cluster object. If you click down here, you'll notice that there's an extended properties view for that role, for the resource in that role. And a lot of these are things that you probably aren't going to adjust too much. This is this Boolean and or list of dependencies that we saw when we took a look at that dependencies report back in that last nugget. I can create and insert additional dependencies if I want. I can do some additional work here with policies to determine when this resource fails, when do I want to attempt the restart, and why. I can adjust the advanced policies here, which just give me some additional functionality here for how things get moved over associated with their possible and preferred owners as well. A lot of these are probably just a step beyond what's required for the exam. And to be perfectly honest, it's these advanced sorts of policies that are where you can kind of get in trouble in terms of the number of dials and switches that you can flip and turn for configuring failover and failback on a clustered resource. So I want to just kind of gloss over these because I don't want you to dig into these too far, at least at this point, because I've seen it happen far too many times where misconfigurations in these locations end up creating some really unexpected results. Now there is over here in the settings screen one item that I think you should be aware of. There's 3 different items here as far as what do you want to do when the virtual machine goes offline, what the stop action should be, take it offline or mark it as failed. The big one down here called heartbeat setting is a new feature that Microsoft wants you to be aware of. This heartbeat setting lets the cluster identify whether or not the virtual machine is responding or not. So are you responding? And then if the virtual machine has its firewall correctly configured to support heartbeat monitoring, and if in addition to the firewall, if it's part of the same domain or a trusted domain, I can actually do automatic recovery for application health monitoring as well. Now, what does this mean? This means that if I turn on specific services that I'm interested in the cluster to look for, the cluster itself can actually go about restarting those services in the virtual machine if you experience some sort of service failure. This is a nice thing. If you know you've got services that occasionally fail from time to time, you can have the cluster handle restarting those on your behalf. Now, the location where you're going to do that happens here under More Actions and to Configure Monitoring. Again, you got to have the firewall set up so that the cluster can actually talk to the virtual machine. And then after the firewall is set up, then you also have to make sure that this virtual machine is part of the same domain or a trusted domain. I think those firewall settings are called like virtual machine monitoring, and there's 4 or 5 of them that you'll want to set up if you've got firewalls turned on inside your data center. Once that's done, once you've got all that configured appropriately, well, then you'll see this list of services here. These are the services that have been interrogated that are on that virtual machine. And if I select one of these services, like the DTC, for example, then the cluster will monitor for the functioning of that service. If it should fail, the cluster will restart the service on your behalf. Awesome little solution here if you know you got services that fail from time to time. So what have we talked about in this nugget? We've talked about VM movement and all the really cool technologies that exist in today's Hyper-V world for getting virtual machines, the brains and the body, moved around across the hosts and storage in your environment. We talked about the 4 different types of VM movement and how, well, you can go from the nicest of these down to the least nice of these in terms of the import, export, and copy VMs process. We also discussed some of the prerequisites, just the things you got to be aware of in order to support all these different types of movement. And then once we brought our virtual machine on our cluster, we took a look at some of the advanced cluster features that are now available to us, like health protection, drain on shutdown, and some of that really cool virtual machine monitoring. Coming up next, we are going to continue this look at movement and migration as it relates to virtual machines. But we're going to take a step even further into the highly advanced, technologically advanced technologies. Because there may be some times with virtual machines that are of extreme importance for your environment, your tier 1 most important machines, that even a failover is not protection enough. In those situations, you may need to have multiple virtual machines that are replicating to each other in lockstep. That replication can protect you against a failure, can bring that second machine online very quickly, can even protect you from an entire site failure. Talking about site-level fault tolerance is the topic for our next nugget. So until then, I hope this has been informative for you, and I'd like to thank you for viewing.